Okay, different kinds of telescopes. So now, for each different part of the electromagnetic spectrum, we have designed different telescopes. The one that you and I are going to buy, if you go to the store, you're not going to go buy an X-ray telescope. You're going to go buy an optical telescope. The optical one is the one that you view through, okay? So these are telescopes that are intended to view in the visible light spectrum. These are the ones that are available for retail sale. There are two major kinds of optical telescopes. Refracting telescope. These are the very first telescopes to be invented. When you go to the Griffith Observatory, they still have the replica of the one Galileo used. Very old. The 1605, it was invented. Galileo used this to discover the moons of Jupiter. Remember how we said, oh, wow, that was shocking. He discovered moons. No one had ever discovered moons before. The basic idea of these lenses, you see these ones here, it says refracting and reflecting. These are the two major kinds, you see. This left one is the refracting. So what do you notice here? You notice there's a curved lens called a primary lens. The light goes through that curved lens, and it forms an image here at the focal point of the lens. And then your eyepiece takes that image and then forms an image through your eye, and then you get to see it. So it has an eyepiece, it has a primary lens. This one here is the second major kind. So the refracting telescope, so let's get to that a little bit later. The reflecting telescopes, they use two or more lenses. So one lens is here, and the other one is the one that you look through, the eyepiece. You see? This one here. Some of the problems that they could cause, and then we have to try to fix them, is they can cause a problem called chromatic aberration. Chrome means from the Greek word to mean color. So chromatic aberration is a problem having to do with the splitting the colors of the wavelength. They split white light into different colors and make the image fuzzy. To correct for this, you can use an achromatic lens. So this picture will show you this. So this shows you what the problem of chromatic aberration means. When the light beam goes through the primary lens, it tends to split up into blue image, yellow image, red image, you see. So not all of them bend as much. They bend differently. So what you're going to have is basically you're going to have, let's say you're looking at a star, you're going to have a star that's going to be kind of widened and it's going to blur. And then you're trying to look through the eyepiece of that, it's going to look a little blurry. So what they do to correct, achromatic lens. So if I ask this to you on the test, which I'm likely to ask, okay, remember, refracting one has the problem of splitting the colors. Why? Because it has a lens in the front. To correct for it, you achromatic. A means to negate that problem, to fight against that problem. So it fights against chromatic aberration. And what it does, it doesn't perfectly cure the issue, but it makes the red and yellow images overlap. Maybe the blue is still a little bit off, but it's better than not having it, okay? Secondly, especially when you try to build bigger and bigger reflecting lenses, refracting lenses, the problem is going to be, let's say you were an astronomer and you wanted to make a really huge one of these, really, really, really big, maybe the size of this room, you know? Well, as this gets bigger and bigger, notice how heavy this thing is going to get. The middle is so thick. So if you're trying to build one the size of this room, the middle has to be about this thick. That glass is going to weigh a lot, okay? So the problem is you can't support it from the end, from the behind, right here. The light has to go through. So the only point you can support from is the two ends. Well, since you can only support from the two ends, if it's a heavy mirror, it's going to tend to sag over time, okay? We call that sagging, okay? So it's going to be heavy. Because it's heavy, it's going to be costly because you're going to need a lot of glass to build it. And it's going to sag. If you try to build big refracting telescopes, they will get heavy and start to sag, and they will cost a lot. So when the telescope designers were first working on this back in the 1800s and early 1900s, they tried to build bigger and bigger refracting lenses. They noticed it was so heavy, they would carry it on wagons and stuff like that, and cars, and it was just so heavy. They gave up on that. I believe this is the biggest one that I'm going to show you here. This is the biggest one that still remains to this day. And it's actually not that big in modern day standard. It's in Chicago. It's the biggest refracting telescope in the world, biggest of this kind. It's 20 meters length, but what I mean by saying the biggest, it's the biggest aperture. Lens 1 meter. Well, in modern day standards, that's not really that big. 1 meter is about this big. You see, about this thick in the middle, about this big. So it's really not that big, but it still probably weighs a lot. Then you've got see here, the astronomer is down here, and then they're viewing it. And then the top is over there. So that is the biggest. It's in Chicago.